Hello everyone, welcome to our session like AI skills which relates to understanding about the machine learning or deep learning program, and basically to give you a thorough review about what are those machine learning algorithms, what are those deep learning algorithm or deep learning models, what they do, and what are the downstream tasks that has been applied for this machine learning and deep learning algorithm. Before diving deep into those bases, we need to understand what are these networks and how do they work. So in our today's session, I'm Dr. Teacher, and I'm going to like make it easy about the topic multi-layer perceptron. Perceptron like simply means like a simple neuron. Basically, if we go with a perceptron based neural network, they can solve a uh, non-linear functionality. And then there comes a multi-layer perceptron that introduce non-linearity within the network. And so this is AI scale, and let's dive deep into multi-layer perceptron. So if we talk about the multi-layer perceptron, is like a single processing unit of any neural network. And this was first proposed by Frank Rosenfeld in 1958, and is a simple neural network which is used to classify its inputs into one or two categories. And in the figure, like we can see, like we have a feature vectors input x1, x2, x3, and we have a weights that makes a connection between one neuron to the another. And in the case of this big circle, there is a computation of linear sum between inputs and biases and weights, and then those functions are passed to the activation that can be like sigmoid, ReLU, Licky ReLU, stepwise activation functions. And then after that we predict the level of that samples. And here in this case, like output, we compute the loss between predicted and expected outputs, and that is called the loss. We will discuss about this in detail later on. So in this case, like if we discuss about input layer, like input layer is made of artificial neurons and takes the initial data in the system for further processing, which simply resembles the dimensions that makes up a connection between input to the next neuron. Bias are the intercept added in a linear equation. It is an additional parameter which task is to modify output along with the weighted sum of input to the other neuron. And activation is like, you can simply think about this like as a transfer functions that transfer specific inputs to its output. Okay, this is like a mapping function. So this is the pictorial representation of multilayer perceptron. Is a fully connected class of feed-forward artificial neural network that generates a set of output from a set of input. MLP is characterized by several layers of input nodes connected as directed graphs between the input and the output layers. Maybe if you have a concept about directed graph, then that's okay. If you don't have information or basic knowledge about directed, acyclic graph, cyclic graph, undirected graph, then please check out some powerful videos related to these directed graphs. And how does the multi-layer perceptron work? So this is the most common questions that we need to ask with ourselves. And it uses a nonlinear activation function that is designed to model the behavior of neurons in human brain. Like it's mimic the real activities how our human brain works. So additionally, multi-layer perceptron has a linear activation function in all its neuron and use backpropagation for phrase training. And if we talk about activation function, I simply say it as a mapping function. How does these functions transform your output to some particular representation, a particular encoding, of particular ranges? So there are different kinds of activation function. The most commonly used is like symbolic a sigmoid function. It's called as logistic functions. Next, hyperbolic tangent, ReLU. Okay, and we need to understand like how does this network work and how the backpropagation algorithm takes place to adjust the weights of the network to make some particular activities. So the algorithm starts when input vector x is entered into the network. This input moves from input layer through hidden layers to the output layer and produce the output y. The loss function is used to compare this output with expected to give an error value called as loss. These error values are then backpropagated from the output layer through the network. This is called as backpropagation. So in the case of forward propagation, it makes a linear sum between inputs and the biases as well as weights, and then it squashes by using the logistic function that transform the inputs to the next network in terms of 0 to 1 in a range of 0 to 1, and this is how the forward pass takes place in multilayer perceptron. And then it computes the total error. Error means the prediction of the network to the real actual outputs. It computes the error. This is the loss function, and then after computing these loss functions, it performs the total error in terms of these errors. Okay, E total equals to E01 plus E02. It's like a batch error. Okay, and if we say this error in terms of large samples, then we call it as like a loss. Is the expected error. Okay, then this is how the backward pass takes place in neural network. You can, I think you guys are very good at like partial derivatives, right? How does it compute the E total with respect to W5, E total upon D out O1 into D out O1 by D net O1 into D net O1 by D W51. This is how it adjusts the weights with respect to particular losses. This is how the backpropagation happens in multilayer perceptron. So this is like truly a morphology about the neural networks. Okay, mostly like in case of if you go to recurrent neural networks or its variant, then it doesn't takes place in terms of all these weights, but it takes place in terms of stats. These are the common things, and the simple things that we need to discuss. I'm not going in detail about all these mathematics, okay? Just I'm giving you the layer so I can discuss more in details about how this multilayer perceptron works and what is the physics behind backpropagation. And when you go with the neural network, sometimes you face the problem of overfitting or sometimes underfitting. Low bias, low variance, underfit. High bias, high variance, low bias, overfitting. This is simply the question that you need to understand, and you can see the examples. If the network tries to learn every behavior, every noise, then it's like overfitting problem. In the case of overfitting problem, especially in machine learning, if you get a better performance at training samples and but low performance at independent sets or test sets, then it's a problem called as overfitting. And in the case of underfitting, if you get not better performance at training samples and also not good at test samples, then this is simply the case of underfitting. So these are the techniques to reduce overfitting. First, you need to increase the training data, reduce model complexity, apply early stopping during the training phase, risk regularization and lasso regularization, or you may say it like L1 and L2 regularization, using dropout for neural network to tackle overfittings, or you can use the weight decay methods. These are the things that you need to know to reduce overfitting. These are the mathematics. Like in the case of uh, alone regularizations, uh, we simply use another regularization term, uh, ohms. The term is sum of the absolute value of weight parameters in the weight matrix. And then, as in the previous case, we multiply regularization term by alpha and enter things to the loss function. We introduce some extra terms to the actual loss that we used previously. Okay, that's only the difference. And think these things in a complex way. Uh, this is the theory behind how regularization work, how does it prevents the problem of overfitting. Okay, if you are interested about these topics also, I will make it more details in the coming of lectures. And dropout, like you can see, like you can visualize from the figure like how the dropout reduce the problem of overfitting. If you keep on using all those neurons, then it tries to understand every noises or every features present within the model. So the problem with this kind of neural networks is that they suffer overfitting problem. And so in order to prevent these problems, then we apply dropout. Weight decay is the next phenomena. We'll dive in detail about this. Okay, thank you, and keep learning. And if you have a query or if you want some particular videos that I want to make, then so please you can ping in the comment and I can make better videos related to the specific topic with the in-depth research. Okay, thank you, have a good day, and keep learning, be happy, healthy, and joyful. Thank you. See you in the next lecture.